Lifetimes of stars. We could say that stars are born, change over time, and eventually die. Most stars change in size, color, and class at least once during their lifetime. Formation of stars. Stars are born in clouds of gas and dust, called nebulas. Our Sun and solar system formed out of a nebula. For a star to form, gravity pulls gas and dust into the center of a nebula. As the material becomes denser, the pressure and the temperature increase. When the temperature of the center becomes hot enough, nuclear fusion begins. The ball of gas has become a star. Main sequence stars. For most of a star's life, hydrogen atoms fuse to form helium atoms. A star like this is a main sequence star. The hotter a main sequence star is, the brighter it is. A star remains on the main sequence as long as it is fusing hydrogen to form helium. Our Sun has been a main sequence star for about 5 billion years. As a medium-sized star, it will continue to shine for about 5 billion more years. Large stars burn through their supply of hydrogen very quickly. These stars live fast and die young. A very large star may only be on the main sequence for 10 million years. A very small star may be on the main sequence for tens to hundreds of millions of years. Red giants and white dwarfs. A star like our Sun will become a red giant in its next stage. When a star uses up its hydrogen, it begins to fuse helium atoms. Helium fuses into heavier atoms like carbon. At this time the star's core starts to collapse inward. The star's outer layers spread out and cool. The result is a larger star that is cooler on the surface, and red in color. Eventually, a red giant burns up all of the helium in its core. What happens next depends on the star's mass. A star like the Sun stops fusion and shrinks into a white dwarf star. A white dwarf is a hot, white, glowing object about the size of Earth. Eventually, a white dwarf cools down and its light fades out. This is the potential end of our star the Sun, based on its mass. Supergiants and supernovas. A more massive star ends its life in a more dramatic way. Very massive stars become red supergiants, like Betelgeuse. In a red supergiant, fusion does not stop. Lighter atoms fuse into heavier atoms. Eventually, iron atoms form. When there is nothing left to fuse, the star's iron core explodes violently. This is called a supernova explosion. The incredible energy released fuses heavy atoms together. Gold, silver, uranium and the other heavy elements can only form in a supernova explosion. A supernova can shine as brightly as an entire galaxy, but only for a short time. Neutron stars and black holes. After a supernova explosion, the star's core is left over. This material is extremely dense. If the core is less than about 4 times the mass of the Sun, the star will become a neutron star. A neutron star is shown in the figure below. This type of star is made almost entirely of neutrons. A neutron star has more mass than the Sun, yet it is only a few kilometers in diameter. A teaspoon of matter from a neutron star would weigh 10 million tons on Earth. If the core remaining after a supernova is more than about 5 times the mass of the Sun, the core collapses to become a black hole. Black holes are so dense that not even light can escape their gravity. For that reason, we can't see black holes. How can we know something exists if radiation can't escape it? We know a black hole is there by the effect that it has on objects around it. Also, some radiation leaks out around its edges. A black hole isn't a hole at all. It is the tremendously dense core of a supermassive star. Thank you friends, for watching my video. This is Sayantan Mandal from India. I hope you all have enjoyed the video. If you like my video, then don't forget to like and subscribe the channel for more updates. And please do share the video, because good things need to be shared as much as possible. Thank you and have a good day ahead.